Hello everyone, welcome to Form 4 Additional Maths, Chapter 4, Indices, Surds and Logarithms, and this is the Part 3 video for logarithms. In the previous video, we stopped at using the laws of logarithms, and this time we are going to try to simplify algebraic expressions using the laws of logarithm. So we go to the example questions. Number 1, express the following as single logarithms. So we have two terms here which we want to combine to become a single logarithm. So in order to simplify this, we need to use the three laws of logarithms that we've learned in the previous video, which is the product law, the division law, and the power law. So since the two laws have the same base, a and a here, and it's plus here, so we can use product law. Okay, so according to product law, when they have the same base, x and y, we just multiply them. So we have this equals to log base a. So x and y, we multiply x and y means we multiply 4 and 3. So we can rewrite it as 4 times 3. Or you can just write the final answer, which is log base a of 12. And B. So now we are performing the subtraction of logarithm with the same base a. So we can use division law because of the minus here. We can combine them by taking x divided by y. However, you see that there's a 3 here. Okay, so we need to settle the 3 here first by using the power law. Okay, so the 3 here, according to the power law, we can move it, becomes the power of 2. Okay, so we rewrite this, it becomes log a 24, and we have log base a of 2 to the power of 3. Then we can perform the division law. So we have log base a of 24 over 2 to the power of 3, which is 8. And you get 24 divided by 8 is 3. So I have simplified this into a single logarithm. So now here we have two terms. One is the logarithm, one is a value. So we cannot simplify this unless we convert 3 in the form of logarithm. Remember, we learned that log base a of a equals to 1, right? So if we multiply both sides by 3, you get 3 log base a of a equals to 3. And we move the 3 here. Using the power law, you get log base a of a to the power of 3 equals to 3. So 3 we can convert to the form of log by using this method. So here we can rewrite this as base 5x plus. But the question is, what values do we want for a? Since for this part the log has a base of 5, so this 3 we convert it so that it becomes log base 5 of 5 to the power of 3. We use 5 for the a here so that they have the same base for the two terms. Then since we have a same base here, we can use the product law, because for the product law they must have, to combine them you must have the same base. Okay, so now using the product law, we get log base 5 of this is x multiplied by 5 to the power of 3. 5 to the power of 3. 5 to the power of 3 is 125, so you get log base 5 of 125x. Okay, for D, we have this. Okay, so the first thing we do is check whether all the terms have the same base or not. We have base A here, but the one without a base A, so we use what we learned in question C, which is log base A of A equals to 1. So in this case, since the first two terms are A, so we just use A here. So we just convert this to this, minus 4 log base A of n minus log base a of a for 1. Now, since we want, since it's a subtraction here, we know that we need to use the division law, but we still have to settle the 4 first by bringing the 4 to the front using the power law. So I rewrite this, it becomes log base a of square root of m minus log base a of n to the power of 4 minus log base a of a. So we try to simplify this part first by using the division law here. Okay, so you have log base a, this will be square root of m over n to the power of 4 because of this. And we still have minus log base a of a. Again, we use the division law because of the subtraction here. So you get log base a. Okay, so this term here divide by this term. Okay, you get m, the square root of m over n to the power of 4 divide by a, which is square root of m over n to the power of 4 a. This is the final answer. So the trick here for question C and question D is whenever you have a single number, you always convert it to log with the base which is the same as the other terms, so that you can use the 3 laws to simplify them. And whenever you have a number in front of a log, you always have to use a power law to bring it to front here before you simplify the terms. Now we look at other types of example. We have example question 2. Given log base a of 2 equals to p, log base a of 3 equals to q, log base a of 5 equals to r, express the following in terms of p, q, and r. So we want to express this in terms of p, q, and r. So meaning that we are going to try to play with these numbers here so that we get a combination of either this or this or this. For example, okay, so log base a of 4, sorry, which is we can see this as log base a of 2 to the power of 2, because 2 to the power of 2 is 4. And if we use the power law here, okay, we can bring the 2 to the front here. You get 2 times log base a of 2. Why are we doing this? Because if we get these terms here, which is equals to this, we can replace it with p. So now this is p. Okay, so we can rewrite this as equals to 2p. So this is the answer. We try again. So we have log base a of 30. We need to try to find the combinations of the numbers of 2, 3, and 5 so that we get the value of 30. So we can see 30 as 2 times 15, because 2 times 15 is 30. Why we want 2 times 15? Because we have a 2 here because of this 2. And 15, we know that 15 is actually 3 times 5. So we can rewrite this as this. So now you see that 30 is a combination of 2 times 3 times 5, which we have here 2, 3, and 5. And now, since it's a multiplication here, we can use this product law here to rewrite this as log base a of 2 plus log base a of 3 plus log base a of 5. And according to the question given that log base a of 2 is p, log base a of 3 is q, log base a of 5 is r, and this is the final answer. Still the same question here, but C here we have a log base a of 0.666. So it's very obvious that we need to rewrite this number or convert this number so that it is a combination of either 2, 3, or 5. If you recall the previous subtopic from the surds, law of surds, we already learned how to convert this recurring decimals to fractions. So we try to convert this to fraction by first letting n equals to 0.666 dot, and then we multiply by 10 for both sides, because there is only one recurring number, which is 6. So when we multiply by 10, I get 6.666 and so on. We label this as equation 1, we label this as equation 2. So when you take equation 2 minus equation 1, okay, meaning that 10n minus n, you get 9n for the left hand side. 6.666 minus 0.666 for the right hand side, and you get 6. So n is equals to 6 over 9. When we simplify it, you get 2 over 3. N is this, which is 0.666, meaning that we can rewrite this as log base a, which is equals to log base a of 2 over 3. Since 0.666 here is equals to n, and n equals to 2 over 3, hence this is equals to this. And if we can rewrite this in terms of 2 over 3 here, we already have this value here, and the rest will be easy. Since this is a division here, we use the division law, and you have log base a of 2 minus log base a of 3. Log base a of 2 is P, log base a of 3 is Q, and you have the answer. Question D here, we have log base a of 3 over 2 sub 5. So since there's a division here, we can use the division law. So we can rewrite this as log base a of 3 minus log base a of 2 sub 5. And since this is we have a multiplication here, 2 multiplies sub 5, we can use the product law here. So you have log base a of 3 minus, for this we have log base a of 2, and then we have plus here, plus log base a of sub 5. So notice that I have a bracket here because log base a of 2 plus log base a of sub 5 is actually one term, comes from this term. So the negative applies to both terms here. The negative here applies to both terms here. So I rewrite this again, I get log base a of 3 minus log base a of 2, and then if I take away the brackets, this becomes minus log base a of sub 5. Sub 5, we can rewrite this as 5 to the power of 1 over 2. And because of the power law here, we can bring the 1 over 2 to the front. So if I rewrite this again, I get log base a of 3 minus log base a of 2 minus 1 over 2 log base a of 5. Then the rest I just replace with the Q minus P minus 1 over 2 R. So always remember, you need to move the power to the front here before you replace this with R. Okay, so you get this is your final answer. So these are the examples of simplifying the algebra expression which involves logarithms. Now we want to look at another formula, okay, which is log base a of b equals to log base c of b divided by log base c of a. So in the next part, we want to try to prove this relationship and also want to determine the logarithm of a number. So now, previously we learned that if you are given the log base 10 over 7, we can just find the value with the help of the calculator. We key in this in the calculator, we get the values. When you are given this, not all the calculators, especially those who only have the function of log base 10, can find the value. So when this happens, okay, we can try to convert or change the log with the base 8 to the log with base 10 by using this formula, which is log base a of b equals to log base c of b over log base c of a. we can see that log of a base a here now is changed to another base, which is base c, where the value of the b is written here and the value of the a now is written here. So we can use this formula to change the base of a log from a to another base of any values that we want. So in this case, we change the base a to base 10 so that we can use a calculator to find the values. Maybe you're still confused, we look at the examples. Example, determine the following values by changing the base to 10. Okay, so for a here, we have a log with base 2. When we want to change the base for any reasons, we can use this formula. Okay, so we rewrite this, it is equals to, you see here, log base c. Base c is the values that we want, which is 10 here. So we rewrite this as log base 10, log base 10, because 10 is the value that we want. And the 3 here, we write here, the 2, we write here. Now we can use our calculator. If you have one with you, you can try. We try to find log base 10 of 3. So how to use a calculator to key in this value, we already learned in the previous video. So I'm not going to cover it here. I just go straight to the answer. You get 0.4771. For log base 10 of 2, you get 0.3010. Then you just calculate the values. 1.5850. Okay, so likewise for question number B, the base is 0.5, so we want to change the base to 10, so we use this formula. We rewrite this as log base 10, log base 10, and the 7 we write here, 0.5 we write here. Then we use our calculator to find the values for both numerator and the denominator. Log base 10 of 7, negative 2.8076. That's it. So now you can see that this formula is very important to help us to change the value of the base to another value that we want. So in this case, we will change it to base 10 so that we can use a calculator to find the values. So now we haven't proved the relationship from the new formula. So we start by supposing log base a of b equals to a value which is x. Previously, we learned that we can change the equation in logarithmic form to equation in the index form. So we bring the a to the right hand side, it becomes b equals a to the power of x. After that, we rewrite this again, and then I find the log of base c for both the values of left hand side and the right hand side. Okay, so we have a log of base c, log of base c here. And according to the power law, I can move the x to the front, so the x will be here. Then I can bring log base c of a to the right hand side to find the value of x. So x equals to log base c of b over log base c of a. And remember, x here is this x, which is log base a of b. So I rewrite this again. I get log base a of b equals to this. So the relationship has been proven. Okay, so that is how we get this formula. And note that the value of a, b, and c here are positive numbers. And a cannot be 1 because, remember, for the base of a log, it cannot be 1. So since c is also the base of a log, so c cannot be 1 as well. So from this formula, we can actually derive a new one. Okay, so we start off with this. Okay, for example, if you have a log base a of b, if you want to rewrite or convert this so that it becomes a log of a base b, how are we going to do this? So we start off with the new formula. So for this case, we want to rewrite log base a of b so that it becomes log with base b. Hence the c here, now we want the c here to become b. Okay, so we can rewrite this as log base a of b equals to log base b of b divided by log base b of a. And remember, log base b of b is equals to 1. So it is this. So from this formula, we can derive another one. So you can see that log base A of B equals to 1 over log base B of A. The positions of these two values are switched. Let us see a few examples for this. So convert log base 5 of 8 to logarithm of base 8. So this is base 5. We want to convert it so that it becomes base 8. So we can use the formula. Okay, so we rewrite this, we use the formula. According to the formula, I can write the value C as any values that I want. So in this case, I want base 8. So the C here is 8. So this becomes 8. And 8 is here, 5 is here. So since the log base 8 of 8 is equals to 1, so now it becomes 1 over log base 8 of 5. But if you understand this formula, you can actually skip this step. And you can start from this, and the next step will be this. The next part is about natural logarithms. Natural logarithms are logarithms with a base e. For example, log base e of 5, log base e of 10. We can also write log with the base e as this, which is L and N. We can read this as ln, so this is ln 5, which means log base e of 5. Ln 10, which means log base e of 10. These are all natural logarithms. And the e here is not an unknown. E is an irrational number with a fixed value, which is a constant, 2.7182. Since it is an irrational number, this is an infinite non-recurring decimal. E is also known as an Euler's number, which if you are interested, you can go and read more about it by yourself, do some research, and you will learn more about this value of E here in more advanced mathematics. There are a few other properties that you need to know about E here is when you have ln E, which basically means log base E of E, it is always equals to 1, and ln E to the power of x is equals to x. And there are a few more properties that you can read from the textbook. So now we look at a few example questions involving natural logarithms. The first one is to convert the following values to natural logarithms, and then we find the values, we evaluate them. So since we want to convert this to natural logarithms, means we want to convert this to log base E. So if we want to change the log with base 2 to log base E, we need to use this formula, which helps us to change the base of the log. So we can use this, we rewrite this, the log here now have the base E, log base E, the 3 we write here, 2 we write here. Now the problem here comes. How are we going to find this value, right? So remember, we learned that log base E of a value is also equals to ln of that value. So log base E of 3 is equals to ln 3. Okay, so you can calculate the value of this, which is this, by using your calculator. So in my calculator, the button is here. You press ln once, and then you can key in the values. You now try to find this value, which is ln 3, and this value here, which is ln 2. You key in the values for ln 3, you get 1.0986. And then you key in the value for ln 2, you get 0.6931. Then you calculate the values, which is 1.5851. That is the answer. Okay, so now we change the base 7 to log of base E because we want to convert this to natural logarithms by using this formula. So we write this as log base E. Okay, so log base E. So the 255 becomes this, and 7 is here. Then log base e is actually ln. Okay, so you can rewrite this as ln of 255, ln of 7, and then use your calculator, you get which is 2.8477. Now after we look at natural logarithms, we come back to this formula again and we'll try to do a few more example questions regarding this formula. So the first one, we have given that log base 4 of x equals to a, express the following in terms of a. So we want to express this in terms of a. So the first thing we notice here is the base is not the same. So when you have different base, the first thing you use the formula and change the base. So now we change this to base of 4. Okay, so log base of 4, the base of 4, and the x is here, 16 is here. So now you have log base 4 of x, log base 4 of x, which is a. So now you have this becomes a. So you have a. And we still have to settle this, the denominator part. So 16, you can see that 16 is actually 4 to the power of 2. And so, using the power law, we can bring the 2 in front. So you get a 2 times log base 4 of 4. And remember, log base a of a always equals to 1. So log base 4 of 4 equals to 1. So you have 2 times 1, you get a over 2. Question B, we have log base x of 4. So here we have base 4, here we have base x, which is different. So it's very obvious we need to change the base by using this formula. So we have this becomes log base 4. Okay? We always try to convert this so that it has a base, the same base as the one given. So we have this base 4. So 4 here will be here, the x will be here. Log base 4 of 4 equals to 1. Log base 4 of x is this. Log base 4 of x equals to a. So the answer is 1 over a. Question C, here again we have a base x, but here base 4. So it's very obvious we need to change it so that it has base 4. So the 16x to the power of 3 becomes 16x to the power of 3. And the x here is here. Now, for the denominator part, it's very obvious that it is equals to a. However, for this part, it is not done yet. So since 16 multiplies x to the power of 3, we can use the product law. So this becomes log 416 plus log base 4 of x to the power of 3. And then, since 16 is 4 to the power of 2, and using the power law, we can bring the 3 here. We get 3 multiplied log base 4 of x over a. So why we want to bring the 3 in front here? Because we want to get log base 4 of x, which is equals to a. And this, the 2, we can bring in the front, you get 2. Log base 4 of 4 is actually equals to 1. And here we have 3. Log base 4 of x is a over a. So we have 2 plus 3a over a as our final answer. Now we look at the different types of question. We have now given that log base 2 of 3 equals to p, log base 2 of 5 equals to q. Express the following in terms of p and q. Okay, so we want to express this in terms of p and q, meaning that you need to convert this into terms which is a combination of this and this. So the first thing we always look for is the base. You see this has a base 5, here we have base 2. So we change the base 5 to base 2 by using this formula. So you have 2 we use the brackets because we are changing this part. Okay, so we have this is log base 2 because here is base 2, log base 2. The 3 here I write here, the 5 here I write here. You can see that log base 2 of 3 is actually P, log base 2 of 5 is actually Q. So you get 2P over Q, which is 2P over Q. That's it. Still the same question here. Now we have B. We have log base 3 of 4 multiply log base 5 of 16. Okay, so again the first thing we do is we check the base. We have 3 and 5 here, but here we have 2 and a 2. So we change the base by using this formula. So you have this, we rewrite this as log base 2 over log base 2. So the 4 here is here, the 3 is here. The same applies to this as well, log base 2, and 16 is here, 5 will be here. Now, log base 2 of 4. Since there is no 4 here given, so we just try to find the values. So we have log base 2 of 4 is 2 to the power of 2. And log base 2 of 3 is actually equals to P. Log base 2 of 16 here is log base 2 of 2 to the power of 4. And log base 2 of 5 is Q. And we just find the values. If we bring a 2 here, you get you have 2. Log base 2 of 2 is 1. So if we bring a 4 here, log base 2 and 2 is 1, Q. And you have 2 times 4, you get 6. P times Q, you get P, Q. So this is the end of this video. In the next video, we are going to look at the final part of logarithms, where we are going to try to solve problems involving the laws of logarithms and also problems involving indices, surds, and logarithms to conclude chapter 4. I'll see you next time. Thank you.